Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So here in this video, we'll go for what are the different elementary operations on a matrix here. So these elementary operations are very important to calculate to find out the inverse of a given matrix here. Now basically we are having some 6 different elementary operations. So these are also called as some elementary that is the transformation of a matrix. So here we are having some 6 elementary operations, out of which the 3 is due to the rows and 3 is due to the columns here. Means what, we can apply the elementary operations, 3 elementary operations for the rows, and the same elementary operations we can apply for the columns also. So the total it becomes a 6 here. Now we will just study one by one in detail. So the very first elementary operation is we can interchange. So I'll just write here. So interchange of any rows and columns. Interchange of any rows and columns. So now just see here. So here basically, so any rows and columns, if I take for the rows, it is a separate one elementary operation with respect to the rows, and if I just apply the same elementary operation with respect to the column, it becomes a second, that is elementary operation for the column. So now in this elementary operation 1, it will be having both for the rows and the columns. So means what? So the same elementary operation we can apply for the rows as well as the column. Now if we just study this one, so it's nothing but it gives some 2 elementary operations here out of 6. Okay. Now what it means? So interchange of any rows and the columns. So interchange of any rows and the columns is how we can explain. If I take matrix A is equal to like 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, let it be. So this is somewhat like, okay, some given matrix A here. Now for this matrix A, so according to this operation, what we can do here? So this is a row 1, this is row 2, and this is a row 3. C1, C2, C3. So we can interchange this row 1 with respect to with R2 here. So means what? If I take this is R1, this is R2, so we can represent this operation as like this. So I can interchange the row R1 with R2 here. We have to express with the help of this double arrow here, which indicates which means that so we are interchanging the row 1 elements, the complete row 1 with respect to with R2 here. So this is what we are interchanging here. Now when we write this condition, the matrix becomes A is equal to, the row 1 becomes row 2, but the row 2 becomes row 1, means we have to keep it in that place here. Okay. Now this is 4, 5, 6, this is 1, 2, 3, this is 7, 8 and 9. So in this case we are not changing the elements of the row 3 here, because only thing is what, we are just doing the operations only for the row 1 and the row 2. So you just see here, this is the row 2 elements which is kept in a R1 place, and this is the row 1 elements which kept in a R2 place when we interchange the R1 with R2 here. Now this is basically a elementary row operation. If I apply the same operation for the columns, what happens? If I take the same matrix here, okay, now what is the condition? If the next thing is what, I'll apply the elementary operation for the column. If I take C2 interchange with C3, C2 interchange with C3 means what? So this is C1, this is C2, this is C3. So according to this operation, C2 I have to interchange with the C3 here. Means what? I have to replace this C3 in place of C2, and C2 elements I have to replace with in the place of the C3 here. So finally the matrix becomes A is equal to, the column 1 elements will be remain same, we are not changing with this. Okay, this is 3, 6, 9, 2, 5 and 8. Now this is the column element after interchange. Now what is the application of this matrix here? Because we have to solve, because the basically thing is what, so we can able to solve the system of linear equation in a simpler manner. So with the help of this matrix we can solve here. Similarly, if I interchange with the rows and the columns, okay, I am not get disturbing with the system of linear equation. If for example, if I take a linear equation like this, okay, 1x plus 2y plus 3z is equal to some 11. So similarly, if I take 4x plus 5y plus 6z is equal to some 12. So similarly 7x plus 8y plus 9z is equal to some 13 or any 14. Okay, we know that these are the some system of linear equations. This is the equation 1, 2, 3 here. Now, so the main thing is what? Here the coefficient matrix of this system of linear equation, if you just compare with this, the matrix A, it is similar to this one. Similar to this one means if you take the coefficient of this system of linear equation, the matrix what we are getting here is this one. So again in this we will be having some variable matrix is there, some solution matrix is there, okay, let it be. But when you see the coefficient matrix of this system of linear equations, we are going to get the matrix like this, okay. Now in that case, if I interchange these two equations, so means what? The second equation if I write in the place of the first equation, and the first equation if I write in the place of a second equation, we are not get disturbed with the, okay, like system of linear equations, okay. There is no change in the system of linear equation. Means what? If I interchange the equations, there is no change in the equations. Similarly, I can write that coefficient matrix here in the matrix A form, like in this matrix form. If I replace this R2 as R1 and R1 as a R2 here, okay, there is no change in the matrix, okay. Now this is a basically, that is a row operation. For example, if suppose if I take the same that is a system of linear equation, if I write the that is the factors of y first in the place of a x position. For example, if I take this is a first equation, if I write like this, 2y plus 1x plus 3z is equal to 11. Similarly, if I write the second equation in this format, so means what? The y term should be first. If I write, there is no change in the equations. 7x plus 9z is equal to 13. So means what? Even if you just write the y as a first term and x as a second terms, there is no change in the equation. Similarly, if you just interchange the first that is the first terms into the second and again second terms as a first here, like this, there is no change in the matrix as well as the system of linear equation. By this method, there will be a helpful of this elementary operations here, okay. Now this is a basically what we can interchange the elements of all, that is a we can interchange the rows and the columns in a matrix here, okay. Now let us move on to the, okay, what will be the second operation? This is the second important elementary operation here, that is the multiplication of the elements of any rows or columns by a non-zero number. So means what? If I take like this matrix A is equal to again like 2 3 7 4 5 8 3 2 1, okay. If suppose if I take this is something like matrix A, okay, which is of order 3 cross 3 matrix. So what we, according to this operation, multiplication of the elements of any rows or columns by a non-zero number. So means what? If I take this is the row 1, row 2, row 3 or C1, C2, 3, any, if you take any row, either you can take the R1, R2, R3, or you can take the C1, C2 or C3. So we can multiply any of these rows with a constant, that is a non-zero number. So means what? If I just apply this operation here, I can write it as, so suppose R1 changes to 2R2, sorry 2R1. So means what? I am just changing the matrix, sorry, that is a row 1 here, that is the elements of the row 1. Means what? I can write this R1 as R1 changes to 2R1. Means what? I can multiply the elements of this R1 with 2 here. So means what? Finally what I am getting here, so A is equal to, if I multiply this 2 for the row 1 elements, it becomes 4, 6, 14. The remaining R2 and R3 elements, we are not multiplying with any number here, because we are doing the operation is only for the R1 elements here, okay. We just keep as it is here, 4, 5, 8, this is 3, 2, 1, okay. This is also how we can able to multiply, how we can multiply a constant, that is a non-zero number, for any of the rows or any of the column here. So here we have multiplied the 2, that is a constant non-zero number 2 for the R1 elements, which is 2, 3, 7 here. So we are getting 4, 6, 14 here, okay. We are not get so then there is no change, there is no, okay. This is for the row operation here. Now similarly I can apply this rule, that is the operation for the column matrix here. So if suppose if I take some C2 is given by some 2C2, means what? I am multiplying a non-zero number, that is 2 for a C2 elements, then the C2 elements becomes changes here. So how we can represent here? C2 changes as 2C2. So means I have to take, so this matrix A becomes, so I have to multiply the 2 for the second column elements, because this is C1, C2, C3. So C1 and C2 will be remain same, there is no change here, 2, 4, 3. Only we had to multiply 2 for the second column elements, it becomes 6, 10, 4. Again the C3 elements become remain same, we are not doing operation for the C3 elements. Now this is what we are getting the matrix here after the, when we apply the second elementary operation, that is C2 changes as 2C2. So means what, we can multiply any non-zero number for the rows as well as the columns. Okay, so this is a very important second elementary operation which can applicable for the rows as well as the column here. So it gets totally, it's a 4 because the row is for 3 and therefore due to the column the remaining is 3. So we have studied now, it's a totally 4 because the 2 is for the rows and 2 is for the columns here. Now finally we will go for the, what will be the third elementary operations of a matrix, that is addition to the elements of any row or column. Okay, or column, the corresponding elements of the any row or column multiplied by any non-zero number. If suppose if I am taking the matrix A is equal to some 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a matrix what we have taken. Now so what is made, what we have, okay, so now according to this operation, addition to the elements of any row or column, addition to the elements of any or row or column is, if suppose I have to change the elements of R3 here, so we can add for this R3 elements by multiplying a non-zero number for any of rows or columns. If I even I can take the R1 or R2. So means what, if I want to change the R3 elements here, I have to add the same elements of R3 by multiplying a constant, that is a non-zero number, with any of other rows or columns. Because we are doing the row operations here, we have to take the rows here. Okay, now the matrix becomes A is equal to, so this is a 7, 8, 9 is there, this is actually the elements of R3, plus we have to what, we have to multiply the 2 with the R2 elements, then we have to add the elements of this corresponding elements here. I will multiply this 2 for the elements of R2 here, it becomes 2 4s are 8, plus I have to add a corresponding element of the same R3 here, so it becomes 15 here. So that is, we have to write it in the place of R3 position, that is a row 3 elements. Okay, similarly 2 5s are 10 because we are multiplying with the row 2 elements, 2 5s are 10, plus we have to add with the R3 elements here, so it becomes 18 here. Similarly 2 6s are 12 plus 9, so it becomes 21. Okay, so this is what we have changed the elements of R3 here, but the remaining other 2 rows will be remain same because we are not we are not applying operations here for R1 and R2, we just keep as it is here. Now this is what the elementary row operation for the third one. So similarly if I take the same matrix here, now if I want to apply the column operations for this, so I can write this as, suppose if I want to change the C2 elements, so I can write like this, C2 changes to C2 plus 2C1. If I take, this is the 2C1. Now we know that this is C1, C2, C3, the matrix A becomes, so we are changing the elements of a C2 means, first I will write the C1 and C2 as it is here, that is 1, 4, 7, the C3 will be remain as it is 3, 6, 9 here. Okay, now I want to change the values of this C2 here. How we can change this, how we can make changes here means, I have to multiply a 2 for this element here, so it becomes 2 1s are 2, plus I have to add the C2 elements here, that is a plus 2 I have to add, multiply 2 1s are 2 here plus 2, it become a 4, again 2 4s are 8 plus 5, that is 13, 2 7s are 14 plus 8, that is a 22, 2 4s are 2 7s are 14 plus 8 is 22. Okay, this is a matrix what we are getting here by using a column operation. Now finally we just conclude what we have done so far, like 6 elementary operations. So we can write the 6 elementary operations as, that is elementary row operations. So there is 6, this is again 3 elementary column operations we can take. So first one is what, so we can interchange the rows or columns. If suppose you can take R1 interchange with the R2 here, So here also I can interchange with the R1 as, sorry, C1 as C2 here. So in general I can take this is the ith row and this is jth row, and this is a column here. Second operation is what? We can multiply a non-zero number for any of the rows or columns here. So suppose if I'm changing the value, that is the elements of a R2 by multiplying a non-zero number. So instead of 2 or any number, if I write like k constant here, which is a non-zero number, it becomes kr2. Okay. Similarly, if I apply the for a elementary operation, column operation, so C2 I can write it as kc2. Okay, in general. So for a standard purpose, I'll take this is ith row. So here I can take I or j, you can take any matrix, any you can take I or j k. Now the very third important elementary operation is what? According to this, I can change the row R2, means this is the row R2 plus k R1, like this I can take. So similarly for the column operation also, so this I can take it as a some C3 changes to C3 plus k C1, like this we can take. So for the reference, for a standard I can take this is a j is equal to, so this is j, this is I can take, you can take any value here also, this is I. Okay, now these are the summary. In standard we can write the 6 elementary operations of a matrix is, or this is 3 for the elementary row operation, this is for the 3 is for the due to the elementary column operations, and this is how we can summarize here. Now in the next class, okay, in the next video we'll move on to the what is the invertible matrices, and based on that we'll be having some one simple properties there. Okay, and what is the uniqueness of the, okay, like inverse of a matrix in the next video. Please, if you like this video, comment, share it to your friends. Okay, and subscribe to our channel.